Hi there. A, B, C, D, E, F is a regular hexagon in which AB represents the vector P and BC represents the vector Q. Expressed in terms of P and Q, the vectors which represent the remaining sides. Now, first we'll start with ED, and when we say ED, I'm not talking about a vector, we're just talking about the length ED is equal and parallel to AB. So it's actually P. So we can write that ED, the vector, the displacement vector, ED is equal to the vector P, or is represented by the vector P. Similarly, we have that FE is equal, FE is equal to BC. So we can write that FE is equal, or is represented by the vector Q. Now again, FE is the length. We're talking about lengths here. We notice we haven't used the notation for vectors, and only here we've indicated it, which gives the direction from F to E, which is represented by Q. Similarly for ED. Now AD, again it's a length, is twice as long, and it's also parallel to BC. Why is this so? Well, if we look at AD, we have an imaginary line here. Why is it twice? In a regular hexagon, we have equilateral triangles here. We have 1, 2, 3, 4, 5, 6 of them. Now, BC is one of the sides of this, of any equilateral triangle. So here we have 1 of them and 2 of them, which is the length of AD. So it's twice as long as one length, which is BC. So we can write that AD is equal to 2 of Q. But what we have is the relationship that CD is equal to CB added to BA add together. I'll say instead of added, we'll use the plus sign as expressed as together with AD. And now we can replace these with the vectors that they represent. We have CB will be going in the opposite direction, so it's negative, opposite sense. BA, again, AB is positive, so BA would be negative. And we know we just calculated AD, which is 2Q, which gives us the result Q minus P. Now AF is equal and parallel. So AF is equal and parallel to CD. So we write that AF is equal to also Q minus P. So we've covered all the sides, the remaining, so we were given the sides AB and BC as P and Q respectively, and we've covered all the other remaining sides and expressed them in terms of P and Q. Pay close attention to the notation here. When you don't see an arrow or an underscore, which indicates that it's a vector, then it's considered the magnitude of, let's say, E to D, and not a vector. Thanks for watching. I'm Alistair.